Hey guys, in this video I'm going to show you a simple trick that you can use to find exact trig values in just a couple of seconds. And I'm going to go through 6 different examples to show you exactly how this trick works. Now before I start, in order to answer these types of questions, you need to know two things. The first thing is that you need to know how to find exact values of the basic or reference angles, and the second thing is that you need to know how to identify which quadrant an angle lies in. Now if you need to learn those two things, I've done a separate video for each one of them. I'll leave a link to those videos in the description box below. So watch those two videos first if you're not up to scratch with knowing your exact values of the basic angles and also identifying which quadrant an angle lies in. It's going to help you better grasp this video as well. Anyways, looking at part A of the questions that we've got, we want the exact value of sine of 3 pi on 4. To do this, we're going to need to use the two triangles that I discussed in my previous video. The 45-degree or the 30-60-degree triangle. Now the trick here is to first ignore the constant in the numerator, the constant that's in front of the pi. And so for this question we're going to ignore the 3 and only look at the pi on 4 bit. Pi on 4 is the basic angle. And so the trick is to simply state that the sine of 3 pi on 4 is equal to the sine of the basic angle, which is pi on 4. The only thing now is we need to determine whether this is going to be a positive or a negative. To do this, we need to find which quadrant the angle 3 pi on 4 lies in. 3 pi on 4 is 3/4 of a pi. 3/4 of a pi means that we're in the second quadrant. In the second quadrant, we know that sine is positive. And so this means that sine of 3 pi on 4 is going to equal the positive of sine of pi on 4. Looking at the triangles, sine of pi on 4 is going to be opposite over hypotenuse, which is equal to 1 on root 2. And so sine of 3 pi on 4 is equal to 1 on root 2. Part B. We want the tan of 2 pi on 3. And so ignoring the number in front of the pi, which is the 2, we're left with pi on 3. And so the basic angle is going to be pi on 3. And so this means that the tan of 2 pi on 3 is going to equal the tan of pi on 3. Now we just need to work out whether this is going to be positive or negative. And so drawing the four quadrants, the angle 2 pi on 3 is 2/3 of a pi. And so this is going to be in the second quadrant. In the second quadrant, we know that tan is negative, and so this is going to be the negative of tan of pi on 3. Looking at the pi on 3 triangle, tan of pi on 3 is going to be opposite over adjacent, and so this is equal to root 3 on 1. And so tan of 2 pi on 3 is equal to minus root 3 on 1, which is just minus root 3. Part C. We want the cos of 5 pi on 6. And so ignoring the number in front of the pi, we're left with pi on 6, which is going to be the basic angle. And so the cos of 5 pi on 6 is equal to the cos of pi on 6. Now we just need to work out whether this is going to be positive or negative. And so drawing our quadrants, again, 5 pi on 6 is going to be in the second quadrant because this is 5/6 of a pi. In the second quadrant, we know that cos is negative, and so this is going to be the negative of cos of pi on 6. Looking at the triangles, the angle pi on 6, the cos of this angle is going to be adjacent over hypotenuse, and so this is going to be root 3 on 2. And so cos of 5 pi on 6 is going to be minus root 3 on 2. Part D. We want the cos of 4 pi on 3. And so again, ignoring the 4, we're left with pi on 3. This means the base angle is pi on 3. And so the cos of 4 pi on 3 is going to equal cos of pi on 3. Only this time we need to work out whether this is going to be positive or negative. And so drawing our axes, the angle 4 pi on 3 is the same as 1 pi and then 1/3 of a pi. And so if we go 1 pi and then 1/3 of a pi, this means we are in the third quadrant. in the third quadrant, we know that cos is negative, and so this is going to be the negative of cos of pi on 3. And now looking at the triangles, pi on 3, the cos of this angle is going to be adjacent over hypotenuse, which is 1 on 2. And so cos of 4 pi on 3 is going to equal minus 1 on 2, which is minus a half. Part E. The tan of 7 pi on 6. Ignoring the 7, we've got pi on 6. And so the base angle is going to be pi on 6. And so the tan of 7 pi on 6 is going to equal tan of pi on 6. We just need to work out if this is positive or negative. 7 pi on 6 is the same as 1 pi and then 1/6 of a pi. And so in our quadrants, we've got 1 pi and then 1/6 of a pi, which means we are in the third quadrant. In the third quadrant, tan is positive. And so this means that tan of 7 pi on 6 is going to equal the positive of tan of pi on 6. Looking at the triangles, tan of pi on 6 is going to be opposite over adjacent, and so this is equal to 1 on root 3. And so the tan of 7 pi on 6 is equal to 1 on root 3. Part F. Sine of 11 pi on 6. And so ignoring the 11, we're left with pi on 6. And so the basic angle is going to be pi on 6. And so the sine of 11 pi on 6 is going to equal the sine of pi on 6. We just need to work out if it's positive or negative. 11 pi on 6 is the same as 1 and 5/6 of a pi. And so if we go 1 pi and then 5/6 of a pi, we're going to be in the fourth quadrant. In the fourth quadrant, sine is negative, and so this is going to be negative. Looking at the triangles, pi on 6, the sine of pi on 6 is equal to opposite over hypotenuse, and this is equal to 1 on 2. And so sine of 11 pi on 6 is going to equal minus 1 on 2. And that's it for this video. Now if you like this trick, then give this video a thumbs up or comment below and let me know. Good luck with your studies, and I'll see you guys in the next video.